Well, howdy, physics sleuths and inquisitive souls. Welcome to another episode of Dynamic Gravity. So, in this episode, we're going to dig deep into virtual particles and what that means for dynamic gravity and how they think it works and how I think it works, which means essentially how I think gravity works on a subatomic level. I'm not going to lie, we're going to dig really deep on this one. We're going to go really far down the rabbit hole, hopefully rock bottom, but you never know till it's too late. So let's get on with it and let's see how it goes, shall we? So, virtual particles are basically particles that transfer forces and physics, right? So you got like bosons and all this stuff, the weak force, the strong force, it's all, propagated by virtual photons. Well, so is the electromagnetic force, which means, according to dynamic gravity, so is gravity. It is also propagated by virtual particles. And the virtual particle that propagates the electromagnetic force, hence gravity, as we will say, is the virtual photon. Now, excuse me, brain damage from the war. Virtual particles, it's a weird thing. It's essentially a math trick, okay? There's really been no virtual photon or virtual particle that's ever been measured in a laboratory anywhere. It's never been measured. But it's a math trick that we devised to kind of quantify like a field of force specifically, which is how we believe gravity works. And so we believe that these things are real because without it, we have zero clue how force can be transferred from one particle to another. It's literally impossible. But with the virtual particle math trick, we can kind of get an idea of what's going on a little bit. This is the whole virtual particle physics is very theory oriented, where there's a whole lot of people that have a whole lot of ideals of what's going on, but nobody really's got a whole lot of proof to back it up. You know what I mean? It's kind of the wild, wild west of physics right now. So let's see if we can throw our hat into the race and see what we get her. So yeah, virtual particles, they're particles that they aren't real. They don't have real energy or mass like a real particle does. But yet they kind of do. But the more mass it has, the less lifespan it has. Like it can borrow mass from the space foam, the quantum foam, whatever you want to call it, the ether. And the more mass it borrows, the quicker it has to give it back to keep equilibrium. So when you come to virtual particles like photons, like virtual photons, which will propagate the electromagnetic force, like we have here, the Coulomb's static electric force, and even the magnetic field, they, for some reason, claim that these particles, we know they have infinite range, which means they never give back what they borrow from the quantum foam. So, physics says, well, that the only way that can be is that they have no mass, no energy, nothing. They're literally nothing more than a figment of our imagination that explains what's going on. And for obvious reasons, we're going to break into this and we're going to rip this to shreds like a hungry bear. It's going to be bad. But I digress. So the Coulomb's electrostatic force between electric charges is caused by exchange of virtual photons, right? Virtual photons. Oh, they have a cute little picture there. That's not what they look like. I'm sorry. Hate to break your heart, sunshine. In symmetric three-dimensional space, the exchange result in inverse square law, which is how we know gravity works. That is what gravity's power level is an inverse square law. For the electric force, since photons have no mass, the Coulomb potential has infinite range. So we know it has infinite range. So the only way they can rectify this is by proactively going back and saying, well, it must have no mass. Otherwise, it's impossible. But if it has no mass, how is it going to do any sort of force transfer like you claim? Yeah, problems. We're going to dig deep. Very deep, children. Very deep. The magnetic field between magnetic dipoles is caused by the exchange of virtual photons in symmetric three-dimensional space in exchange of inverse cube law for magnetic force. That's news to me, a cube law. Maybe because it's got a lot of curl and it's bending in and it's forcing it to come out one end and go back in through the other. I don't know. Maybe. Since the photon has no mass, the magnetic potential has an infinite range. Very interesting. So we know that virtual photons exist because of experiments done, like the one to validate the Kashmir effect. Right. So the Kashmir effect is essentially you have like two plates, very close to each other, but not touching, very close. And they're saying that these virtual particles are just popping in and out of existence everywhere, blah, 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 blah. Long ones and short ones and big ones and small ones and all the ones everywhere. And if you have two plates together, the ones that can propagate or create themselves and manifest themselves inside the radius of the two plates is very small, but outside is very large. So you're going to have a force from nothing that's going to push the plates together. And we have observed this. This is a thing. It does happen. So, the virtual particle trick explains this, relatively nicely. There's a nice little, diagram showing, you got little ones being made in between, but a lot of big ones outside. And overall, the force is just more outside, and it basically pushes the plates together. Very interesting stuff. Not much more down the Kashmir effect rabbit hole, other than proof that virtual particles are somehow in some way a thing. But there's a problem. They say that, because we know it's a fact, that virtual particles for the electric and magnetic force are infinite in range. We can measure this. But the only way this can work out, according to the way the current theory of virtual particle works, is if they have no mass. But according to good old Einstein, E equals mc squared, and I don't think this is the exact full equation. I think it has to include momentum or something into this one, but it's close enough for our generic explanation. Essentially, energy translates to mass, and mass translates to energy. This is a thing. So if the particles have no mass, because they have infinite range, then that means they have no energy, which means they really can't do much. They have no energy, no mass. How much are they really going to affect the system? This is one of the many conundrums of virtual particles. that have made me pay attention and notice this problem in physics, where it's like, yo, you guys, your math is not adding up. I'm sorry, but it's not. It's all haywire. It's all messed up. You guys are cray cray. So yeah, we know that our version of how virtual particles work is definitely not on the level. There's definitely much more we have to learn when it comes to virtual particles. All right. Now, here is a generic diagram, kind of showing you got two electrons together, and oh, this one's exchanging a virtual particle with this one, and that's forcing this one to go further away, and they're repelling each other because they're two electrons and they're like charges and they repel each other. Cool story, but how is that really working? Well, the diagram shows you it's like a wavy thing, and it's going in between, and if you don't get it, I can't help you. Yeah, that's the problem. Main physics can't help you. Not if you have questions like, what the fuck is going on here? How do you have two particles repelling each other? Or even more difficult, attracting each other, with virtual particles, like virtual photons, like we suspect, the electromagnetic force is propagated by. And you see they have this neat little diagram here of a wavy thing with two arrows. and that makes the electrons repel each other. Well, there you have it right there, folks. Problem solved. No need to look any further. We're all good here. No, we're not good. We're not even close. We haven't even begun yet. So, one of the more popular opinions on how virtual particles work is like, here is a Feynman diagram, right? And you got like two electrons, right? These two electrons, and they're coming close to each other. And then as they do, they exchange a virtual photon. That's what this represents. And then they all of a sudden decide, well, hey, I'm going to go away. My bad. They start at the bottom and then go away at the top. I apologize for my ignorance. So yeah, they exchange. You got two electrons. They come near each other. They exchange a virtual photon, and then all of a sudden they magically go away. Well, that explains everything, doesn't it, folks? Everything. No, seriously, you guys need to have serious standards here. This is ridiculous. Yeah, and this is just a Feynman diagram of a virtual particle causes repulsion between two electrons. Image. Yeah, well, that just explains not a goddamn thing. So we dig a little deeper, right? And I accept all cookies. Sure, why not? And we got two different examples of how physicists, want to make you think that these things work. Don't you dare challenge them. You don't have an academic email. You don't have the right. So one of them is that a virtual photon has mass, and you have mass. And it's like you're holding a bowling ball, and the virtual photon is a bowling ball, right? And you throw the bowling ball. And when you push against the bowling ball to make it go away from you, you're exerting force, your force, which is pushing you back. And as you push the bowling ball forward, you push yourself back. Like this cat rot her. And then as this bra over here in the other boat catches the bowling ball, he's receiving that momentum of the force that you pit towards him, and he is catching it, and it's pushing him back, right? A simple concept, but I would like to remind you that they clearly said, since the photon has no mass at all, it has infinite range. So this little lovely diagram of there we go. Lovely diagram of pushing a bowling ball with mass back and forth with each other to create a force to make you go further and further away makes absolutely zero sense. Zero. Welcome to physics, ladies and gentlemen. So, and then you're like, and it gets even crazier. You're like, well, okay, fine. So you can explain how two particles repel each other. What about two particles that attract each other, like a proton and an electron? And they're like, oh, that's simple. Pretend like instead of throwing a bowling ball, you're throwing a boomerang. And it's just like, whoosh, and it's like spinning around with the air pressure, and the air pressure is making it like a wing, and it's going this way and that way, and it goes in a big loop all around. It comes right back around to you. Only instead of coming back to you, it comes back around to your bra in the boat next to you. And it's like, okay, I mean, technically, that is a thing. I'm not gonna lie, that's a thing. You can exert force, throw in a boomerang, and recoil you back, and then catch the boomerang from behind you, and then have it pushed up forth back. You know, and if you have two separate entities that intercept the boomerang, it will exert force. Force pushing this guy this way, and force pushing the other guy towards him, towards the middle, theoretically. But now we're getting ridiculous. Now we're like, okay, first of all, we haven't even addressed the real issue in the clown and the circus yet, which is that photons, virtual photons, have no mass, according to physics. Hence, they have infinite range. So how is it possible that something with no mass is going to have recoil when you throw it? No mass, no energy. It makes no sense. This is the best physics can offer you, children. This is the best they have for you. Because they don't understand gravity. And they don't understand the world we live in. Do I? I don't know. Listen to my theory and let me know if you think it makes more sense. We're going to get there. Give me a minute. This is going to be a long episode. I'm really sorry for that. I apologize, but it is what it is. So, apologies, brain damage. All right. So, we've got their description of how this whole thing works. And, you know, it's not insanity. I mean, there's some evidence for it, right? Because here we have electric charges, right? We got a positive field pushing out all of the electric virtual photons, and the negative entity of that receiving them. And I know that's how the equations work, but in reality, because we have the electron, the negative entity, and the proton, the positive, it should really be reversed. But whatever. Let's not even start that war just yet. All right. And so one of the things that happen, as you can see, is, with electric static particles, like a proton and an electron, like these could represent. You could say, well, there it is right there. There's the boomerang. Look right there. This field of line goes outward behind this one and then leaps all the way around. It comes back and hits this one in the back. And so there's your attractive force right there. Boom. Done. Solved. Game over. No. Because, first of all, this field of line is definitely not going to have as much power or force as this field of line going directly in between the two. And these ones going directly in the two, you're going to say are going to act like the bowling ball throwing it back and forth between the two people. So it is literally impossible to have this diagram and have an electric, or my bad, not electric, an attractive force bringing these two particles together from the way this is described by this diagram. It's literally impossible. There's absolutely no way. It's impossible. And as you can see here, these like two positive charges, the field of lines, they're not even exchanging direct links. They're like, no, we're going away. We repel from each other. We're not going to be exchanging things. No. So none of this makes any sense at all. None of it. And the deeper you look into it, the more confused you're going to get, because the more people you're going to have trying to explain it rationally with their logic and their insanity. And sometimes you can make insanity sound really good if you have a good way with words and people, and you understand how to present things to where people are like, oh, that sounds great to me. This is all ridiculousness. Look at this. This is stupid. Oh my God. Okay. So, here is a thing that kind of the exchange is but how does the exchange of such balls exchange attraction between unlike charges? So we have two different charges. How are they brought together by these virtual photons? And this is probably one of the more technical things I found explain it. An electron and a proton, there's quite a range of commentary at each point. Some commentaries and analogies use basketballs attached like the throw or the elastic string, so the ball goes forward, but with negative momentum transfer. Others talk about it like negative energy, with negative mass, even going backwards in time. Antiparticle pairs, some delve into the math like perturbation theory on how probabilistic vectors result in appropriate momentum transfer. That's a very technical way we have of saying we have no clue, but this kind of sounds like a cool story, right? No, brah. No. And I believe, if I'm not mistaken, somewhere here, they also go off to their explanation of it. I think the problem with analogies, you really have to imagine a virtual basketball, recognize different properties. Like a real basketball moves in a direction and carries momentum in that direction. When you catch a basketball coming from your left, of course, you must carry momentum, push to your right, blah, blah, blah. Here we go. How a virtual response were possible for repulsive electromagnetic forces is what we really want to know. This phenomenon is currently not as intuitive as a picture in one described in one question. The photons being emitted and absorbed are thus transmitting momentum and can be understood in the same way. Consider for the momentum particle with negative mass and how one would respond to a push from a photon, and one would move a particle opposite direction, causing attractor referred to. Now imagine somehow charged opposite and the virtual photons to behave as if the particle had negative mass. So, according to their theory, it's all the same virtual particles, virtual photons being emitted from electrons and protons. But yet, one is got to have negative mass for this whole thing to work out. I kind of agree with these guys a little bit. The problem is they're stupid and they're trying to make this work with one virtual particle. But there's not. There's two. I know. It's mind-blowing. Let that settle for a second, and we're going to move on. Maxwell's equations, the ultimate authority regarding the electromagnetic force, which is why I always keep coming back to this damn thing, because it is what it is. His first equation demonstrates basically electric charge and how that electric charge creates force. Excuse me. Brain damage. Apologies. So, this P, I think, represents like density of charge or something. I don't know, something like that. And then this E sub naught 0 is like the electrical conductivity of like space itself. And so, by doing this, by dividing electrical charge by electrical conductivity of space itself, you can get an electric field, which is what this equation is all about telling you. It's basically saying, hey, look, an electric field is created by a charged particle. And when you have a negatively charged particle and a positively charged particle, like a proton, an electron, excuse me, the virtual particles are going to go from the electron to the proton, like water falling from a waterfall, from a higher elevated place to a lower elevated place of more equilibrium. There's too much energy in the electron, and so it's going to give it to the proton. That's what Maxwell says. I personally say bullshit. You're wrong. I know. I'm so ridiculous calling out Maxwell. But hear me out, and then we'll decide. So, we have, okay, yeah, this is from a while ago. Let's just delete that bad boy, and okay. So, we're going to have, let's say, a proton, right? A white object, a white thing of charge, of anti-charge. And we are going to have an electron. And the electron, of course, is going to be, dark, because it's going to have all the juice, all the electron stuff, according to Maxwell. Right? And so this is how it goes. So virtual photons are emitted constantly from the electron, always going in the direction of the proton. And they're going to come out all directions. But guess what? They're going to kind of make a roundabout thing because they're attracted to this proton. And they're all going to go in this proton. And this, proton is just going to suck them all up like a vacuum cleaner, It's like this electron is just spitting out virtual photons, bloop, 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 bloop. And the proton is just sucking them up. Like, yeah, lay them all on me. Give it all to me. And that's how this goes, right? And that is the problem with trying to explain this. You cannot explain attractive and repulsive forces with just one set of virtual photons only being emitted from the electron and absorbed by the proton. And of course, they know that protons emit virtual photons as well. But according to Maxwell's equations, the way it works is, let me see here. Here we go. Divergence, I believe it's called, and flux, whatever. And it's like, okay, you got two particles, and you can see, they're emitting the virtual photons. Although on this one, it's coming from the positive to the negative, which is kind of reverse from what I know it to be, but whatever. Let's just say that's the way it is. So let's say the proton's emitting all the virtual photons, and the electron is absorbing them all. Right? And then they have, this thing where it's like, okay, you have an area, And the way you define how much electric charge is by how much the direction of flow of the charge in that area. And if it's all going the same way, then there is no charge. But if there's a difference, then you have some charge. And whenever you have a difference going this way, you have to have somewhere else with a difference going this way to receive that charge. One pushing the charge out, one receiving the charge. Do you understand? This is how modern physics defines virtual photons. And, I'm not saying they're wrong or anything, but yeah, okay, I am. They're wrong. They're totally wrong. So, this is totally not what's going on. And another thing to think about is it's almost like the law of thermodynamics, all right? The first law of thermodynamics says energy cannot be created or destroyed. Well, that sounds an awful lot like E equals mc squared to me, brah. Like either you have energy or it converts itself into mass. Or you have mass and you convert yourself into energy. It is what it is. You have what you have, and you can convert the two from one to the other, but you can't fabricate something from nothing. Makes sense, right? So the second law for spontaneous progress, entropy of the universe must increase. This is basically saying that you cannot consolidate charge or heat. It will always want to propagate outward. And the third law, a perfect crystal of 0 Kelvin has 0 entropy. This is essentially saying that, listen, if you have a room and this side is really hot and this side is really cold, they're going to mix through entropy and it's going to equalize the temperature. You cannot have differences without some force holding that too. If there's no energy being put in the system to separate the heat from the cold, they're going to mix and it's going to equalize and you're going to have equilibrium and it's just going to balance out to whatever it is meant to be. Right. So, knowing that, if we pretend that the proton and the electron, like let's say the electron has all the heat, right? All the juice, all the virtual photons, then what is going to happen is this thing is going to shoot all of its juice, all of its glorious virtual photons to where they are not so dense, to a less dense region, right? Equilibrium. So you naturally have somewhere with lots of virtual photons going to somewhere with not so much. The problem is we know this can't be true because if we put two protons together, they are going to repel each other. All right? And if a proton or electron, whatever way you want to look at it, is defined as the absence of virtual photons, and the other is the presence of that, then you cannot have force between two objects that are the absence of, because there's nothing there to create force with. So we know this doesn't work. This is all bullshit. Pardon my French. Excuse me. So, we got this thing. All right? Now we're going to dig in a little bit into my theory, what I think, now that we've seen what modern physics has to offer. This is all modern physics I've talked about so far. And if it doesn't make any sense, it's not my fault, dude. It's all those physicists. They're like, but I'm special. You have to agree with what I say because I'm smart. Cool story, bro. So, we got this thing called black body radiation. And essentially, this means that any heat you put into a system is going to be released from that system in the form of photons. So, let's say we have a chunk of metal and it's room temperature. It's going to be emitting all of the photons that are associated with the energy levels of room temperature. And if we heat it up a little bit, maybe to where, say, it's glowing hot, red hot, now it has got enough energy that the molecules have enough heat, energy, that they're moving around constantly, emitting photons, real photons of infrared spectrum, which are transferring that heat, that energy, that everything to everything around it. And, there's lots of charts here that show you, like, hey, at this temperature, it'll go and it'll emit these photons, Like here it tells you, yeah, here's the infrared spectrum. Here's the visible light it will emit. Here's UV. It goes all the way up to gamma rays. Basically, the hotter you make an object, the higher energy photons it's going to release. But it's not just going to release those higher energy photons. It's going to release all the photons beneath that as well. So if you heat it up hot enough, say, to release UV light, it's also going to be emitting visible light. It's also going to be emitting infrared light. It's also going to be emitting radio waves. It's going to be emitting everything, the spectrum all below it, simultaneously at once. And there's this thing, right, with good old Einstein, where he did, called the Bose-Einstein condensate, right? This is a thing he worked out. One of the many things he did that was legendary. And basically, what they did is they predicted that if you took away all the energy of a particle, then what would happen is that particle would not have enough energy to hold itself together, and it would just merge into this single waveform of plasma, essentially, that is called a Bose-Einstein condensate. So something is absolute zero. It has zero energy of heat being thrown into it, and it is unable to even hold itself together as a particle. It cannot do it. It just reverts back into this plasma state with no form and no function. And as soon as you throw some heat into it, it will magically be able to hold itself together with the heat that you give it. Well, here's what I propose. I propose that the heat that you're giving it, and this happens, I think, like 2.7 degrees Kelvin or something, according to math and what we've seen. So it's very, very small. They're very close to absolute zero. Like at 2 or 3 degrees Kelvin, the atom now has enough energy to hold itself together. So here's what I think is going on. I think that as an electron is moving around, and even a proton too, from heat being above absolute zero, that's giving it the energy to move. And when it moves, it creates photons. This is how photons are created, is when an electron moves up to a different higher energy orbital and goes back and it releases that energy in the form of a photon. Well, a virtual photon allegedly has no energy, but we know that virtual photons are not emitted when there is no energy, because otherwise matter reverses into a Bose-Einstein condensate. So a virtual photon has to have some energy because it can't make itself without energy. So there has to be energy involved. So what I think is going on here is you have, right, like a proton. All right. Oh, wow, that was just disappeared, didn't it now? And then we got like an electron. All right. Now, as the electron moves around, boop, 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 like it's constantly absorbing all of these other photons. And if you watch my other video, I explained how I believed that photons are essentially microparticles of charge from their parent charged particles. All right. So you got like a little bitty charged particle, right? And it came off from the Big Bang, whatever, and it hits this electron, and bloop, it gets sucked into it. And then the electron grows a little bit. And then the electron decides to move around because now it's changed the charge density of the electron, and now it's different, so now it's going to move. And as it moves, it becomes unstable, but it wants equilibrium, and it's all quantized. So it goes back to its original state and hence releases the same amount of energy it absorbed, and it comes back out. It's a charge. That's what I believe photons are micro charges, which hence means micro masses running around muck through the universe. All right? So you have any amount of energy above 2.7 degrees Kelvin, whatever the number is, where all of a sudden these electrons are able to move around just enough where they can emit these virtual photons. And they can emit a lot of them. I mean, we're talking a lot. Like for every one real photon that's emitted, we may be talking about thousands of virtual photons. They're just like ping, 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 just constantly shooting out from this thing, just constantly wiggling from it having the energy above 2.7 Kelvin. Right. Well, I believe that the proton is also doing this. But while these virtual photons coming from the electron have a negative charge density, because that's where they came from, a negative energy. It's essentially a tiny piece of negative energy being broken off from the electron, boop, and shot out because, you have two likes and they repel each other and they just go. Well, I personally believe that you have a bunch of positively charged virtual photons that are constantly being emitted from the proton. So what you got is you got a bunch of tiny electrons constantly shooting out of the electron. And you got a bunch of tiny protons constantly shooting out of the proton. Right? Well, what happens? Okay, say these two interact. They meet and they just annihilate. Poof. They just disappear. They both meet and annihilate. They turn to energy. I don't know. They go back into the quantum foam. They make other particles. I don't know, man. It's beyond me. I'm not there yet. But whenever these particles shoot out, they're going to shoot out at a certain rate. And it's going to be the same rate that you would have like when they're coming out, the density. Like you see when 3 of them coming out at the same time, they're all very close, and so the field's going to be very strong. As they go away, the field's going to weaken. So this right here can easily explain why we have a fall off of energy and force between particles. Because the closer you go to the particle, the more virtual photons you're going to encounter. And the virtual photons, like let's say they go ping right here, right? From the proton to the electron, right? All right, so now you've got a huge negative entity with a very small positive one. All right. So what that's going to do is they're going to annihilate somehow. I don't know how. I don't know the specifics. I'm not there yet. And I probably never will be. Not in our lifetime. But somehow, because this positively charged bit of the proton hit the electron, it is going to annihilate and create some sort of vacuum implosion, maybe. Instead of an explosion, it could maybe create an implosion, which create force, to pull you towards. I don't know. There's many different ways this could happen. But essentially, you have a very small positive entity striking a very large negative entity. And the result is this positive entity is going to get destroyed. Boop. And the negative entity is going to ever so slightly go just a little bit closer to the proton. And when the same thing happens with the electron, the little bit morsels of electric density strike the proton, it is going to annihilate that little bit of negative energy and make the proton go just a little bit closer. And they keep doing this over and over until they achieve basically a distance where they're comfortable. And remember, protons have an electron inside of them. I did not know this till recently, but they do. So that's why they never actually collide and crash into each other, because there is always a negative density charge built into the proton where it will repel the electron, keeping it at a distance it is comfortable with. And if there is no electron in the proton, then it's just 3 up quarks, and it will immediately suck up the first electron it finds. It's like, boop, gone. And then now we'll have the negative density into it, and it will now repel the electrons at a safe distance. So, this is basically how I believe virtual photons work, and hence gravity on a subatomic level. You have a particle like a proton and a particle like an electron, and they are both emitting microparticles, which we call virtual photons, from themselves, that they are gaining constantly from the universe being hotter than 2.7 degrees Kelvin, and there's constantly absorbing and throwing these particles out, and it's moving them around, and that is what we call heat. That is the physics definition of heat. And that is the only way that you can get both a repulsive force, like say if you have 2 protons, that are becoming closer to each other. That's the only way you can have a repulsive force between 2 like entities, like 2 protons or 2 electrons, and have an attractive force between a proton and an electron. They both have to emit completely different and opposite virtual photons. And you might be asking, Well, okay. I mean, we can measure the virtual photons coming from the electron. This is essentially an electric field, and a magnetic field. We can measure this. We know this is a thing. But do we really know that the proton is actually emitting its own virtual particles? Well, I would like to ask you this. If gravity is truly a force, right? And it seems to work very similar to like a magnetic or electric force does, as far as attraction or repulsion, whatever. Um, then gravity would also have to have its own virtual particle that does what it does, right? So, by essence, by the fact that we can measure gravity, is proof that we can measure the virtual photons coming from a proton. Think about it. So, yeah, that is pretty much everything that I have going into this episode on virtual photons. I am so sorry that this took so long. This is a huge deep dive. We went so deep into the rabbit hole. I don't even know which direction it's up anymore. I'm sorry, but I hope you now have a better understanding of how virtual photons can work. And I hope you have a healthy skepticism of how modern physics says they work, because it doesn't work the way they say it works. There's no way. It's impossible. There has to be something else going on that we haven't figured out yet. And this is what I propose. This is what I think is going on. And if this is true, it 100% collaborates and proves my theory of gravity, dynamic gravity, to be true, and the fact of life and how everything is. So I hope you have a better understanding now of virtual photons. I wish I could dig deeper into it, but my God, this episode's already breaking into an hour. I gotta stop it. I'm sorry. If you need more instruction, I'll do another video if there's demand for it. Other than that, I wish you a good day. Farewell. Bye.
Like, subscribe, submit.